Hi everyone, I hope you're okay. Uh, this is the seventh video, guys. Simply means I'm doing question 7 from the November 2023 Physical Science Paper 1. If this is the first video you come across, please note that there are 6 videos before this one, whereby I'm answering all the first 6 questions. Each question rather has its own video. You can download the question paper, uh, answer the questions with me. If there are things you are not sure about, don't be afraid to ask on the comment section. I'll definitely respond. Okay. 2 point charges A and B, each with a charge of positive 3 nanocoulombs, are stationary on a horizontal surface. Point P is r meters from charge A and 2 r meters rather from charge B, as shown in the diagram below. The first thing we are supposed to do is to describe an electric field. An electric field is a region in which a charge can experience an electrostatic force. Are we together? Okay. And then 7.2, we are supposed to draw the resultant electric field pattern due to charges A and B. Both charges A and B are positive, so there won't be any form of attraction between the two. Both of them are positive charges, and I know that like charges will always repel, no? It will be like this. The field pattern will be like this. The field pattern will be like that, now. And then we are told that the magnitude of the net electric field is 27 newtons per coulomb. Okay, we are given the net electric field at point P. We are supposed to calculate the distance r. But before we do that, I want us to draw a free body diagram for the point charge P. Remember that, guys. Whenever you are given a point charge, you must always assume that it is positive, né? And that point charge is 1.6 times 10 to the power negative 19 coulombs. Are we together? Always the time you must assume that the point charge is positive unless they tell you that it's a negative point charge. Okay, we are given the net electric field, right? So at point P, the point charge P will experience a force of repulsion due to charge A. Force of repulsion due to charge A, né? And the force of repulsion as well due to charge B. You can see that, guys, my two lines are not of the same magnitude. Are we together? This one is greater than this one. Why is that? Please remember that, guys, from your Coulomb's law, the electrostatic force is directly proportional to the product of the charges and inversely proportional to the square of the distance apart. So if the distance is smaller, it simply means that the electrostatic force that will be experienced will be greater. Are you together? But if let me do these ones in blue. But if the distance apart is greater, then the force will be lower. If you can see here, between A and P, the distance is smaller than the distance between P and B. Are you together? So I'm expecting that the repulsion force due to A will be greater than the repulsion force due to B. Are you together? And if you can check, all these 3 charges are positive, né? However, our point of reference is point P. We want to see how does P behave in the presence of these two charges, right? So firstly, charge A will push charge P to the left, and then charge B will push charge A to the right. And then that's how we end up with this free body diagram showing the forces that are experienced by charge P. Okay. Then now we are supposed to find the distance between A and P, but we are given the inert, right? I know that inert is equal to the electric charge due to the electric field due to charge A plus a negative electric field due to charge B. Are you together? Why the other one is negative? Because B is pushing charge P to the left hand side. Are you together? So if I'm choosing any movement from the right towards the right to be positive, that means any movement towards the left will be positive, right? Please note, guys, that whenever you deal with vectors, you must always choose your direction. Okay. Yeah. Okay. So I know that my inert will be equal to E of A minus the electric field due to B, which simply means that inert is equal to K QA over R squared minus K QB over R squared, right? However, the inert is 27 newtons per coulomb. K is 9 times 10 to the power 9 multiplied by positive 3 nanocoulombs all over R squared. The distance between A and P is R, right? Same thing applies here. 9 times 10 to the power 9, 3 times 10 to the power negative 9, but the distance is 2R all squared. Are we together? So this will give me 27 being equal to I'll have 27 over R squared minus 27 over 4R squared. Now all I need to do, guys, is to solve for R, right? I'll just multiply every term by my LCD. My LCD is just 4R squared. So whenever I do that, I'll say 27 multiplied by 4R squared. I'll simply get 108 R squared. Whenever I multiply 27 over R squared by 4R squared, the R squareds will cancel one another. I'll be left with 108. And then on the other side, I'll be just left with 27, right? So I simply have 108 R squared is equal to 81. Then R squared is 81 over 108. So I'll just take the square root on both sides. R will be equal to, let me punch my precious calculator, the square root of 81 divided by 108, root 3 over 2. I'll simply get 0.87 meters. So R is simply 0.87 meters. Are we together? So R 0.87 meters. And then now we are supposed to calculate the magnitude of the net electrostatic force that an electron would experience if placed at point P. The net electrostatic force, I'll answer that one here. Remember that, guys, E is equal to force all over charge. Are you together? So for me to find the force, I just need to multiply the net electric field and the charge of an electron. So my net electric field is simply 27. Charge of an electron is 1.6 times 10 to the power negative 19. what do I get? 27 multiplied by 1.6 times 10 to the power negative 19. I'll simply get 4.32 newtons. That's how it's 4.32 times 10 to the negative 18, excuse me, newtons. So that's how, guys, we're supposed to tackle that that question 7, the free 13 marks that you were given there. So the force here, the force is equal to 4.32 times 10 to the power negative 18 newtons. Yeah, so just stay tuned, guys. Question 8 is coming right away.